Hello everyone, I am Srujan from Bangalore Institute of Technology from Computer Science Department. Today I am going to explain about hazards in combinational logic circuits, specifically static. Today we are going to learn about combinational logic circuits, what are hazards, what is static one hazard, and how to correct static one hazard. What are combinational logic circuit? A combinational logic circuit is a type of circuit in which the output depends only on the current state of its input. A combinational circuit doesn't have any backup or previous memory, hence does not store any previous state of its input, and it depends only on the present state of the input. Unlike the sequential circuit, in which the output depends not only on the present input but also on the state of the previous state of the circuit. Combinational circuits are used in various applications like in digital electronics such as computers to perform operations on data. Combinational circuits can be made using various logic gates such as AND gate, OR gate and NOT gate. Here is a block diagram which shows a combinational logic circuit. Here there are M output lines and N output lines. These M output lines varies depending upon only the N input lines and not on the previous input states. Coming on to hazards, when we are designing asynchronous sequential circuits, certain care, restrictions and precautions must be taken so that the circuits operate properly. The circuit must be operated in a fundamental mode with only one input changing at any given time and must be free of critical races. Hazards are anything that is unwanted switching transients that appear at the output of a circuit because different paths exhibit different propagation delays. Hazards occur in combinational circuits where they may cause temporary false output value. When they occur in asynchronous sequential circuits, hazards may result in transition to a wrong stable state. Types of hazards. There are three types of hazards: static hazard, dynamic hazard, and functional hazard. Static hazard. A static hazard takes place when there is a change in an input when there is a change in an input which causes the output to change momentarily before going back to its correct value. Dynamic hazard. A dynamic hazard occurs when circuit output makes multiple transitions before it settles down to its final value. Functional hazard. Functional hazards occur when more than one input variable is manipulated at a time. These type of hazards are non-solvable and is not possible to eliminate them with using logic. It depends upon the architecture and construction of the circuit. Types of static hazards. There are two types of static hazard: static 1 hazard and static 0 hazard. Static 1 hazard. If the output is currently at logic state 1 and after the input changes its state, the output for some time changes to 0 before again going back to 1. This type of hazard is static 1 hazard. Static 0 hazard. Similar to static 1 hazard, if the output is currently at logic state 0 and when the input changes its state, the output changes to 1 for some time and again goes back to 0. This type of hazard is static 0 hazard. Here is a basic timing diagram which shows static 1 and static 0 hazard. Here we can see for static 1 hazard, the output is 1 and due to some change in the input, the output is becoming 0 and after some time it's again going back to 1. Similarly, for static 0 hazard, the output is 0 and after some time, due to some change in input, it's becoming 1 and after some time it's going back to 0. Let's see what is static 1. Let's see more about static 1 hazard. This type of hazard occur when y is equal to a plus a bar. This hazard takes place when the input transitions from 1 to 0. A plus a bar condition should always generate 1 at the output, but because of some hazard, the output will show 0 for some amount of time. Here, let us consider A as 1 and a bar is 0, and at the output 1 or 0 is 1, and when a transitions from 1 to 0, here the output at the NOT gate should be 1, but because of the NOT gate delay for some time, the zeros remain 0 itself instead of 1. So there are two zeros that is given as input to the OR gate. So 0 or 0 will become 0, and so this and this is basically static one hazard. And here we can see after some time this 0 again goes back to 1, and 0 or 1, and the output will be changed to 1 again. So this is complete static one hazard. In the above figure we can see that the NOT gate output takes some time to become 1. During this time there are two zeros which are given as input to the OR gate. This situation takes place for a small amount of time, and hence the resulting output will become 0. The width of the 0 is in terms of nanosecond and is called a glitch, which is the proper word to be given, which is the proper word that is given as glitch. In combinational logic circuit, this thing may not cause any problems, but in asynchronous sequential circuits, major problems can be caused, which can damage the circuit itself. Let us see the timing diagram for static one hazard. Here A is 1, A bar is 0, and 1 or 0 is 1. And when A transitions from 1 to 0, here it is 0. A bar should be 1, but instead of becoming 1, A bar remains 0 itself because of the NOT gate delay, that is tau 1, which is represented by tau 1, so it remains 0 itself. So 0 or 0 is 0, but due to OR gate delay, it remains 1 itself. The OR gate delay is represented by tau 2. After some time, we can see it as the output y is changing to 0, and here after some time the output at the NOT gate is becoming 1. So 0 and 1 is again becoming 1 at the output. Let us consider a circuit which consists of a hazard. Here is an example of a circuit. Let us consider A is equal to 1, B is equal to 1, and C is equal to 1. Let us see how the hazard is occurring in the circuit. A A1 and 1 is 1. C is transitioning from 1 to 0, and here at the NOT gate it should become 1. Instead it remains 0 itself. So the output at the AND gate will also remain 0 itself here. And here 1 and 0 will become 0. So there are two zeros that are getting input at the OR gate. So 1 changes to 0. So there is a hazard that is occurring. This sub circuit can be represented by this K map, and the equation is y is equal to BC bar plus AC. BC bar plus AC. Let us see how we can remove the hazard. To remove the hazard, we can do a simple procedure by taking a redundant pair. Here we are taking AB as a redundant pair, whereas here we haven't taken AB as a redundant pair. And here, on taking AB as a redundant pair, we get the following equation: y is equal to BC bar plus AC plus AB. Let us see how the circuit works after removing the hazard. This is the circuit after removing the hazard. Let us see how it works. A is 1, C is 1, B is 1, and 1 and 1 is 0 is 0, 1 and 1 is again 1, 1, and the output y is 1. And when C transitions from 1 to 0 here at the AND gate, at the output of this particular AND gate, it's becoming 0. And here, because of the delay, it remains 0. Output at this AND gate is remains 0 because of the delay at the NOT gate. The output at this or NOT gate is still 0. So this is also 0, 0, 0, 1, and the output at this OR gate is still 1. So the output is never changing to 0. This is because of the redundant pair A B, which is here. The only disadvantage of using a hazard-free circuit is that it requires more hardware components. As we can see here, there is an extra AND gate that is used, unlike this circuit. Here only two AND gates are used, and here three AND gates are used. So today uh, we have learned a combinational logic circuit, static hazard, and types of static hazard and static one hazard, and an example for static hazard. And also we have also learned how to remove static one hazard. Thank you.